Okay. Good morning. We're back live. We have a bunch of different things we could do today. The key options at the moment. There's more I can do on the visualization port. And there's also more to do on, well, there's more to do on the meta stuff, which we'll get back to. That'll be probably later today. I think what I'm going to do at the moment is something a little bit different. I'm going to try to actually get some good profiling done. And the reason for this is I want PufferLib to actually be close to hardware optimal. And you can't do that without knowing what is hardware optimal. So we're going to just put together a few little scripts, eval MFU, and we'll see whether this seems like this is an area where we can make some decent progress. Let me switch this over to stream view. Yeah, there we go. All right, so yeah, this is what I was looking for. The torch actually has this flop counter potentially. Oh, the one thing we should do before this is we should at least go collect our experiments, right? Do that real quick. Triple triad. Okay. Got this. What's this? Okay. Good for that. And do we have this done? Yes, we do. Okay, so ah, I'm out of I am like out of colors, right? Just gonna use all this. I don't want to do this manually. Why am I using an LM for this? That's like incredibly stupid, right? Here, let's not be dumb. Ah, I see. Hey, Shift Tree. Something related. We're gonna do. I'll go over what I'm doing today after I get the experiment results from last night and get a couple new ones launched. The idea is that we're gonna have all these experimental results, at least our first pass at them, by the time we have, the visualizer set up and all that. Welcome, Martin. There we go, that's a list. That wasn't that hard, now was it? Oh, there's no way to format some strings other than pasting them into an LLM. Like, the thing that bothers me is that it even occurred to me to like, oh, I could just paste this into an LLM and have an LLM do that. Isn't that just like perverse in some way? Like, oh, we could have the fuzzy, incredibly bloated thing reformat some strings. Isn't that like just messed up? Um, isn't there rand perm? LLM to support your APIs. All right, there. This we can do. Hello, I looked into the A-Life thing. A-Life thing? Oh, the conference. Yeah. Okay, I remember. Papers. Yeah, it takes a lot of time, you know? It's not going to be an overnight thing. I can make it a lot faster than if you'd be doing this completely on your own, right? A few points in the right direction go a long way. Ooh, that's actually kind of nice, isn't it? Look at that. The triple triad one right here. You see it's got like this nice curve to it. Why doesn't this get... Oh yeah, because you can't solve triple triad fully, right? You don't ever get like the perfect win rate. But that's like a nice curve, and a lot of these have this shape. This is good. Alright, so, I guess Snake we could just rerun. That's easy, right? But Snake kind of got messed up. Where'd it go? Here? Where was my, my term? Is this it? Yeah, it is. Yeah, it is. What do you think about mathematics in particular? Wait, you think it will be necessary to be a match for the competition? Oh, no. Well, there's like a minimum barrier, but the minimum barrier is very low with respect to what other people think. You need to have seen partial derivatives, multivariate partial derivatives. Well, look, I literally... That tells you all you need to know about my math background. I just said multivariate partial derivatives. More coffee. Yes, you need to have seen partial derivatives, ideally with respect to matrices and things, which not any different from normal. Decent bit of linear algebra, but not really the theoretical, tough proof-based kind, just like the getting very comfortable with tensor operations kind, and a few other operations in there. A little bit of stats is nice. But that's kind of all I have. Like, the way that I do all of my work is by being really, really good at the engineering side. And I'm not even like an amazing engineer compared to some of the like low-level systems people who really know what they're doing. But the thing is, most AI people are such bad engineers that I kind of just blow them out of the water in that department. So it doesn't matter if you know a bunch of math if you can't implement anything, right? There are a lot of different... What I'm saying is there are a lot of different ways to have an edge and to be able to contribute good stuff. You kind of just need to identify an approach that, like, you are uniquely suited to execute in a way that nobody's been able to do before. Do you recommend doing a PhD in RL? I never recommend people do a PhD unless they know that they want to do a PhD, right? So I recommend that you do a PhD if you know that you want to do a PhD. Mathematics. PhD no, statistics is overkill. If you're a math-heavy person and you can find a way to leverage it, then absolutely go ahead, right? But it's not like, oh, that's what you have to do in order to be good at this stuff, right? That's one possible way to... That's like one possible approach. Let's see, this is how I did it. It's kind of awkward, isn't it? I actually don't have a great... Hmm. F. Code looks clean. Some of it, at least, I would damn well hope so, right? Obviously, if you look at my throwaway stuff, it's not gonna be, but the stuff I actually put effort into should be just about, like, yeah. I'm trying to think, like, what is even a good example of stuff I've done lately? There really isn't a ton. Because lately I've been doing all this science side stuff. Oh, wait, let's see. What about PhD, genetic algorithms and evolution? Why exactly are you focused on this class? This is the one that works. Oh, I see. I got the discussion wrong. The RL is the one that works. Genetics or stuff is cool, but it doesn't really work at the moment. Close to this level of clean. Well, it depends what you're looking at. If you're looking at like one of the simpler M's like Snake, Neural MMO3 I could make way better now. The new constellation code will be very clean when I finish it. Oh yeah, this type of thing? Yeah, so this is going to be clean, but then this is not particularly impressive because this is so short. It's very easy to make stuff this clean. This is like, I think this is literally the first env I did in pure C. It should be way better now. You know, I have a couple like hacky prototype M's that where it's kind of a mess, but most of the time I try to keep stuff reasonable. Yeah, of course you can talk to other viewers. It's a chat. It's for chatting. Where ICOM streamers find that disturbing. What? No, that's the point of a chat, is that you can chat. As long as you're generally discussing, like, tech and stuff, and I don't have, like, a political flame war or some bullshit in my chat, you're good. Streamers do not allow that? What the heck? Nuts. Uh, Systems program, want to do some cool RL shit. Absolutely. Honestly, like, so the quick version, if you have that kind of a background, is PufferLib is what happens when someone with an AI background figures out that if you write like basic low-level code that isn't completely stupid, everything is just suddenly 1,000 times faster. And now we're kind of just doing that with everything. Like, you can literally just do basic low-level game dev and actually contribute meaningfully to research. If you're better, there are custom things you can do where you can create all sorts of like game environments that are specifically dedicated to helping us determine or to like understand one specific aspect of our algorithms. There's perf optimization on the whole freaking thing. A lot to be done. C level? Yeah, all of our M's are in C. Honestly, I'd like more of the library to be in C if we could, but the boundary between Python and C is really annoying, and it's difficult to push stuff across it because the Python C API is such a pain. What? C is in the language. C is in the language. Assume you're just joking though. Alright, so this will go run sweep over snake. This will get us a better point for snake. Ida. Still find that daunting. Isn't that like one of those weird... Oh. Eh. You should kind of just write this C. Yeah, you should kind of just write this C. It's not that hard. How can I join the PufferLib thing? Yeah, all my stuff's open source. So, for people who are new here, I am sort of recent-ish PhD graduate. I started Puffer. Puffer's like a private lab. All our stuff is free. It's open source. It's on puffer.ai. You can start the GitHub. Help us out. It's free. We have like 2,000 people total, usually 300 plus online in the Discord. This is where all the dev happens. There are tons of people to help you get started. I have a number of guides on my X here. I have like theory stuff. I have high-level stuff, but then these two guides are pretty much all my advice, all my best advice in one place for general programming and ML if you're very new, or for RL. If you just follow this, you will learn RL. And this is way, way more accessible than the other material out there. It assumes way less math. It pretty much just assumes that you have a decent enough programming background, and like some AI basics. And it gives you a step-by-step on how to get into it and how to contribute to the project. And then once you're at the point where you can build some of these environments, like if you look at these and say, oh yeah, I could do some projects like this, right? And maybe if you've done a couple of them, then that's where you're at the level where you can actually really, really push the research forward and start helping us ask new fundamental questions. And then all the hardware that's behind me over there, we give contributors access to hardware as well once they've done a few things. You don't even necessarily need to have your own hardware. Yeah, this is a comprehensive effort to push reinforcement learning forward. That's what this is. I tend to zone out a lot while I'm working, so I figured that this would be a fun way to like get people involved with Puffer and also keep me focused. When human civilization have, when you build one and PR it. Welcome, Sebastian. For some reason, like, look, a lot of AI background people have like this barrier, this mental barrier to low-level systems programming. I know I was guilty of this as well. But if you just look at the code, like it's really not that bad. Okay? Like this is the Snake environment. It's 200 some odd lines of code. And if you just read through this line by line, like this is really not much longer than the code would be in Python. And the logic is pretty simple. Yeah, there's a little bit of low level stuff that you normally don't think about. But like you don't have to really perf optimize because you can just write loops and the loops are fast. The rendering is super basic because Raylib. You know? What does exactly Puffer need? Code and solve environments. So Puffer needs a lot of things. It depends at what level you're coming in. So for people who just want to learn some RL and want to contribute while having fun, a lot of these game environments end up being directly beneficial to our research because we use these to test our algorithms. And sometimes environments that we don't expect to be hard end up being harder than we expect, right? And then we are able to ask, well, why is that difficult for our algorithm? And we have this new test case in a sense. Plus, we get these cool demos where we can show off, yeah, look, our RL algorithm has learned to do this. It actually plays the game pretty well. And it's not just games, right? We have stuff with drones, we have stuff with driving, we have lots of things. If you have experience in a specific area of industry and want to think about, like, how do we leverage high-perf sim plus RL to solve problems in specific industries, that's useful. If you want to get into the research side, then that's where you start asking what types of environments can we design help elicit problems in our algorithms. That's like another thing, right? Designing custom environments to help us advance specific areas of research. There's the whole research and science side itself, which is heavy experimentation, reading through papers, combining things from different areas of the literature. That requires a little bit more experience. There's like performance optimization of our training and infrastructure. There's general user experience stuff where it's like, okay, we have this really, really complicated thing. How do we just make this easier and easier and easier for people to use and get into? There are a ton of different areas. This is really just a comprehensive effort. And we kind of just leave everything open for people to get involved wherever they want to. The vibe around here. When RL is being run, the entities run simultaneously. Yeah, you typically have like 4,000 or 8,000 parallel environments at a time. The other fun thing about this is because our environments are so fast, we literally train on more data than like all of LLM pre-training. We can go through petabytes of data on one server. That's just how fast sim is. Like some of our sims can produce 50 gigs of data a second when multi-processed. Just like massive amount of data. Ooh, did this thing crash again? Seriously? 400 entities at one time. Yeah, that's because you're not using, like, you're not writing simple low-level code. So typically we can run, on one CPU core, we can run over 1 million steps per second. What types of problems do you want to solve? Guess Tetris or Frozen Lake was done years ago. So yes and no, Martin. Technically, a lot of these problems have been solved, but they've been solved in like a way that's very brittle. They've been solved in a way that's overly complex, and most of them are solved in a way where they're spending like days worth of GPU time on the one individual task. So we have something that is much simpler, much more robust, much more general, and can be run in seconds to minutes on your local machine. So that's just like orders of magnitude of improvement, right? And what we're trying to do essentially is to grow this big library of environments, ideally some of which pose different types of challenges. It's just not necessarily clear up front what types of environments will pose those challenges unless you're more advanced. And then we use all these different environments for benchmarking. So to give you an idea of what I'm doing right now, my latest project is called Puffer Constellation. And this here is a summary of I don't know, like 10, 20,000 experiments here. And these are the best runs of 20,000 experiments. And this is the trade-off between performance, compute invested, and then samples. And then we're going to be able to do all sorts of analysis based on this to really help us understand how our methods work, how they don't work, where they scale, where they don't scale. And I'm going to be running this across all the environments that have been contributed to PufferLib. So this is like one way that stuff gets involved. Now we also do more dedicated stuff, right? Like this grid environment here. You see that this has like this nice like curve, this shape. The grid is an environment that I wrote specifically to test exploration. It is a variable size maze environment, right? Where it's like this very self-contained test of exploration. And then we use this for a lot of our algorithm development to test when we make a change to our algorithm. If it does well on this new environment, it's usually a very good sign. So we need environments that are more reflective of real world challenges. We need some environments that are just plain harder, better challenges overall. We need environments that are like self-contained microcosms that help us test stuff like in context learning, exploration, potentially diversity of strategies, like diverse strategy space where there are multiple ways to solve it. Like there are tons and tons of these. It just depends how far you want to get into the literature to understand these types of things, right? So what I say is when people are new and just trying to do something interesting and learn a little bit about RL, just make some low-level games. That usually ends up being helpful. You learn a lot along the way. It's a very easy way to get into it. And my guide covers all of that. And then as you get more advanced, you sort of start to get into these, this more dedicated area of research. One bin file being executed. That's not how these work, though, Parco. Only optimizing the M's. We are optimizing the algorithm as well. Puffer has the highest performance training implementation. Our training implementation can run up to 5 million steps per second on one GPU. Puffer is end-to-end. It's the M's, it's the bindings, the multiprocessing, the training, the neural net. Like, the whole thing is optimized end-to-end. We have our own hyperparameter optimization routines. We've got our own trainer. We've got our own algorithm. We're not really using a fully standard algorithm anymore. It's everything. And I've written about pretty much all of it as well, if you check some of the articles. So somehow this is still... So this is disappointing because essentially this was supposed to have... I made some fixes to the environment that was supposed to have prevented it from running out of memory, but I think that the machine just ran out of memory. Oh yeah, and then for the folks that are new here, while I'm in this place at least, I have I have the servers behind me and then all the gym equipment behind me. So I train agents and then I train myself throughout the day as well. Let me go reboot that server and get my first set in for today. Puffer typically does GPU for training and then CPU for sim, though we could do GPU for sim. It wouldn't be that hard. You usually just don't need to. No PR for a little bit. I'm down, I weigh like 20 pounds less than my peak. Strength's gonna take a while to go back on. It's 350 for 5, maybe 4-inch elevated. I could definitely pull it off the ground for a few, but I'm taking it easy, trying to get back up. My old PR was 410 for 2, so that was with a belt as well. Being in it. Wait, what did I miss? Everything in Ubuntu? You can run it on whatever Linux. I'm running Ubuntu. HPC and wrapping stuff into C. Well, Martin, there's a little bit of domain expertise that goes with it, right? Because, like, there are a million ways to design HyperFRL wrong. But yeah, it's high-performance simulation, end-to-end optimization. There's some algorithm research. It's just a comprehensive effort to make reinforcement learning, like, broadly successful. Nice mug, thank you. Yeah, we got the... Where is it? MIT does these, like, funny mugs where they just write their logo out of equations from various different areas of science. Periodic tables in there. Yeah, Puffer PPO. There's some advancements in there. It's not just PPO anymore. It's got trajectory segment level filtering based on advantage function. It's got a custom advantage function. It's got a different optimizer. It's got different learning rate scheduling. Just a lot of different things in it that make it qualitatively very different. Development for a while was on Windows. Well, that's just because it was in California, and that desktop just happens to still have Windows on it, which is kind of a bad thing, because if the desktop has Windows, then, like, there's nothing to prevent me from installing League of Legends, and then less work gets done. So the thing is, if I don't have any machines with Windows, I can't install League of Legends. That's the idea. Oh, okay, well, this did run, it seems, and then it crashed later. So I guess we can actually do this. So mystery solved. Yeah, and then the thing about that is that game just makes me mad, and it doesn't even make me mad for all the reasons that people normally get mad. It just makes me mad because, like, I feel like an idiot. I'm terrible at all games, and I feel like a complete idiot for not being able to figure out, so to speak, a lot of competitive games. But the truth of the matter is there's nothing to figure out. It's just I have feet for hands. But it still annoys the hell out of me. So, double distraction, you know? So the idea here is, while I'm here in the warehouse, pretty much all I do is I do research, plus the puffer business. I do exercise, about 3 hours of exercise a day, and I listen to audiobooks. That's all I do. Very focused. Why could end-step Q learning fail? Why could it fail? Are you talking about a specific implementation or the algorithm in general? If you're talking about credit assignment stuff in general, I have a really good article on X, like why RL failed to bootstrap, that talks a lot about credit assignment. 13 years in Korea. B4 to E1. Dude, at least you started B4. At least you haven't seen Iron. I've seen Iron 4, my guy. I have feet for hands. No, my end goal is to revolutionize science, particularly areas of science that depend on simulation, with cracked out reinforcement learning. That is the end goal. Pretty fun one. Did not exist. I see. That's funny. I've played a lot of games, though the vast majority of my time has been on MMOs, which, funny enough, my PhD was basically MMOs but RL. MMOs are the only genre I have ever been good at. Like, top 1%. Everything else, it's like top 1% there, and everything else is like bottom 20, 30%. Okay, so those are these two environments. Now we should have full constellation. Wow, that was a great field for RL though. Yeah, it's my PhD actually was very inspired by RuneScape. Like right down to the tick system in that game. It's just an incredibly well designed environment for RL research. Oh, I missed a message. Hang on, I missed a few messages, didn't I? RS plus gamma. Agent is an elevator, learns to transport people. Oh, yeah, so that's just discounted returns. So it's actually kind of funny. That estimate in Q-learning is biased. So actually you don't want that estimate. It's actually better to decay that estimate from multi-step down to one step, or like few step over the course of training. It's not, well, it's not as biased. It's a better estimate in on-policy learning. My article goes through a lot of this stuff, though. Like, my article is exactly about credit assignment and differences in on and off Pol RL. Yeah, Factorio and like engineering style games have never caught me. I played a little Satisfactory, but it really didn't catch me because it feels like a job, right? The thing with MMOs that always caught me is there's like the long term, what do you go like what are you planning to get towards? And then there's the short term of like whatever mood you're in, there's a gameplay loop that you will enjoy that will feel really good that creates progress towards that goal. Um they're just like perfect. For me, like they're just like perfect. The things are heroin, which is why I cannot install them because science has to be accomplished. Yeah, it's basically like it's designer heroin. Straight up. All right, what I meant to be doing something here. I meant to be figuring out what other environments I want to have on this. Actually almost done with a lot of these. Yeah. Can we do Rware? Probably can do Rware, right? The actual own responsibilities. Yeah, but the difference is that this one produces awesome science, right? How much scientifically useful insight can RL sims provide given current compute architecture limits? And what does Puffer change for this? So Puffer makes everything about 1,000 times faster. That's not marketing or exaggeration. You can go time like CleanRL SB3, see how fast they're typically doing RL. You time us, it's 1,000 times faster. So the idea here, right, is like before Puffer, you had to be Google in order to actually run a reasonable quantity of experiments to figure anything out for sure. Now we're Google, or we may as well be, right? Because we can actually just run tons of experiments to figure stuff out quickly. That's what Puffer changes. There wasn't a compute architecture limitation. It was just like a shitty engineering limitation, and that's what we fixed. Plus, now I'm doing my own research on it, right? You can see that some of our own research that has come out of that's been pretty good as well. And now I'm gearing up to do the largest scientific analysis of RL experiments out there. Yeah, it's like bafflingly dumb. But the thing is, this is my edge, right? Like, I came into this field with an angle that nobody else had come into it with, right? That was my edge. That's why Puffer exists, because it was useful. No pressure. Where do I buy the shares? Puffer's a private company. Can't buy shares of a private company. There is a company, technically two companies behind Puffer. All their stuff is open source. Professionally, we help companies that are trying to do RL and having a hard time of it. We either do custom simulators, we do integrations with our stuff, we do advice and support, we do contracted R&D. Now, this is how Puffer buys the servers. Like to buy the private shares. Mm. You'd have to start doing like good professional work with us, and then you could get a slice of equity. We do actually pull people from the open source community for professional work, but the bar is high. You basically have to be able to do like one of our more complex sims on the website. Like if you can do a project of that scale quickly on your own, or almost on your own, then you're qualified. Premium gaming chair. Do you see this thing? This was the hack that I figured out. Is that actually the office chairs, the gaming chairs, they all suck, alright? What you do is you buy yourself like an actual recliner chair, and it's way better. Us, Puffer. Spencer's also doing stuff with us full time now. Plus the open source community and stuff around it. A couple other people I've pulled in for various things. If you're being for real, I'm going all in. Go ask around. Pretty much everything's out there. The only thing is the bar's high, right? For the professional side. Because Buffer's a small company. This is a new company, right? This is a new thing. And most of my time doesn't go into the business side, right? Most of my time goes into pushing forward the core research. So on that side of things, we really need people who are going to be able to, like, at least have passably decent interactions with clients. Ideally, like, help, scope things, be able to build custom sims, be able to spin up enough on the RL to identify, how to do stuff in a way such that you don't butt up against unsolved problems, or at least know when you're going to. Need some experience. But you can get there, and you can get there quite quickly if you put in the work. And you get a very valuable skill set to boot. Genetic algorithms is interesting. Well, the thing, Parco, is, like, it'll be interesting if you show some result, right? Like, most stuff in genetic algorithms, there really have not been. I haven't seen a ton of promise shown so far. I actually do think that it's possible that you could make stuff work, but you'd have to do it in a way that has not been done so far. Bootstrap the business to fund your own research, pretty much. So not just my own research, right? The goal is to fund, like, a small private lab. Maybe eventually a medium-sized private lab. No investors, Martin. It's bootstrapped. But yeah, pretty much. More tooling on top of PufferLib. Well, this is what I'm doing right now, right? What's this? Like, this is tooling, right? This is going to be open source as part of Puffer. This is not like going into a paid product. This is just going into the open source. There is no paid software product. I buy, when I share some results. Yeah, of course. Why not what, Martin? Yeah, of course. I mean, there are a number of ways I could do this, right? I'm always upfront with people, so Puffer is for profit. It's just not, like, maximum. It's not maximum profit, right? The idea is I'm doing this because I want to advance this area of science, and I think I can make plenty of money along the way. I'm not going to not advance science, and just try to make more money. It's already profitable. Growth has been very good. People have been very happy with what we've delivered so far. The science is going amazingly well as well. Like, the research side is going amazingly. But the thing is, like, yeah. I mean, I've at least, like, I've had plenty of investors talk to me, right? Some good ones as well. But it's, like, inevitably, most of the investors are just going to try to tie you down in ways that conflict with advancing the science. I'd rather do things my own way. Not bought by Nvidia. They're using, I know at least one group internally is using Puffer for some stuff. I'm working on a collaboration with them as well to see if we can get, like, some cool partnerships going. What am I drinking? This is black coffee. This is, 7 out of 10 soda that's not bad for you. They're called Ollipops. So that flavor kind of sucks. Okay, so we now have these experiments going. That took longer than it should have, but hey, I was having a chill time chatting. And we also got all of this. Now we have 10 environments. So this is a minimum of 12,000 experiments, though realistically this is over 20,000 experiments. Pretty cool. And now we're going to start on this stuff. So does this actually exist? Or is this Grok lying to me? Oh. Apparently it is. Okay. So let's just build a little profile thing. And then what we're going to do right now, I should explain. So I've been working on, yesterday I was working on the C port of this experiment stuff. I will be doing more of this week, but I did a bunch of hours of this yesterday and I was starting to get bored. So I'm going to do the other side of this. The goal of this project, right, is very large scale experiments, analysis, and then optimization of hyperparameters to different compute and data regimes. The problem is that Puffer is compute optimized, like it is effective when you run a high data regime. It becomes less efficient when you run lower data regime. And I haven't even really tried to optimize. So what we're going to try to do is we're going to try to get some formal calculations of the efficiency of PufferLib under different settings, and we're going to see if we can optimize based on that. Is there a way to generate games environments? Not really. You kind of just have to write them. It's like the super trendy things like, oh, maybe we can just auto-gen these, but then it just never works. Right? It's less efficient. It's less hardware efficient. So, like, it's fewer... The number of... You're not getting anywhere near the number of flops out of your GPU that you should be. That makes sense. Mixing features. It's very difficult in a way to do that in a way that actually gives you the coverage that you want. World models, yeah, they're kind of just crap. And then the thing is, they're also like orders of magnitude slower. I'm not even like super sure that the approach fundamentally makes sense. Okay. This container needs to be rebooted. Cool. I will be back in a couple minutes, few minutes. And we will continue on profiling, etc. Okay. Whew. Hey, Shiftry. Deadlift's hard. I went from I was doing sets of 335 in California from the ground, and I went to 350 from 4 inches. This actually should be easier. It's just gonna take me a week to get back into the swing of it. I think one more set of those today. Then we have probably leg curls, lying leg curls, and some shoulder work. Eat it. What was I doing with this? Oh yeah, the profile, right? Okay, so like this. Go 30 microseconds. This barely makes a difference. Alright, so flops. What on earth is all this crap? Anything meaningful in this? Alright, just some stream stuff. Ignore this. And we can do flop counter, right? Is there a doc for this? Okay. So what we do is this just prints flops. You see RL going back to CPU? What do you mean back to CPU? Since when was RL on CPU? It's only the environments that are on CPU, not training. GPUs. Well, yeah, but the thing is, like, as soon as ML moved to GPUs, so did RL, pretty much. Like, why on earth would you ever do RL on CPU? Like, the models. Like, technically, yes, you can do it for some of the really small ones, and it's actually not half bad. But, like, we know that the models for more complex problems at least get into the tens or maybe low hundreds of millions. So even if you expect that a lot of problems are going to require that much scaling, that's already too big for CPU to do efficiently. It's fine for inference. Okay. And there's your T-flops. Flops. $82. Yeah. If I go up to this, and um, Got some fatigue on me today. I wonder why. Training or just not sleeping great? Training. Oh, a bit too hot in here as well. Return that in a second. Okay, so let's see if we can do layer. Missing forward function. Forward function. Okay, better, right? Much better. Yellows. Very small difference. Well, this seems like it's saturating, right? If I add in a couple more layers, it doesn't help. What if I just do this? Barely. Let me stick this into, let me just stick this into, oops. Rock. See if there's, like, anything I'm missing. I've done this before and I've gotten pretty similar stuff where like you get only like 50%. And that's no good. We might have to try compile, we might have to try other stuff, but we're gonna get this to work. Putting the question first. I don't have any interest in like context engineering LMs. I'm gonna put the thing, see if I get anything, and if I don't, I'll go figure it out. I honestly hate using these as much as I even do. $40 to 50%. Okay, so we're not expecting. See if this does anything. Peak is 48. I guess there are a couple possibilities, right? Like, it could also be the MFU calc is wrong. Why does nobody do these? Am I crazy, or should there just, like, does it seem like they're nowhere near enough perf tests? And this is consistent with other stuff I've seen. Obsidian Notes guy, nope. I really don't like a lot of structured note stuff. Okay, where is this? Okay, so here's somebody who's done the same thing. Hmm. Let me just try before I like really get into this. Let me see if I can just luck into something, right? The heck? Why is it running both of these? Compile a map mall. That would be wrong, right? Yeah, this is scaled wrong somehow. Oh, this is probably... $50. Well, that definitely spun the GPU fans. Isn't there like this tensor core thingy? Ah, there we go. Look at that. That's it. Oop. It's so annoying though that you literally if you don't set this thing, it just doesn't give you your flops. You either set this flag or you don't get your flops. Much better, right? This is very close to the peak. Try FP16. You get double. Okay, so we have 82. Where's the data sheet? Where's the dang data sheet? Okay. So, AI Terra Ops. Bruh. You can't just do Terra Ops and not give me... Does anybody know where the full data sheet is for this? Why does it not show... Doesn't show more. Okay, so it says non-tensor is 82. What's this 330? Varsity. So we don't care about that. Oh, okay, so this is supposed to be... Hang on, we're supposed to be able to get 330 then, right? So I get 150, but we're supposed to be able to get 330? This is not necessarily crucial, to be fair, but it's possible we can get some good stuff from this. I think it would be really cool to get key flops in the dashboard. We can see exactly what efficiency we're running at. Honestly, the like shared weights, multiple passes through same net stuff, kind of good for this. Hmm. I have to just check if that's actually a good question. Is this doing accumulate somewhere? Oh, it looks like they're like a flag. Oh, is this hang on. Did I read this right? FP16 with FP16. No, I should be able to do this, right? Is there a flag? Well, this is not supposed to be this high. It's mostly they get 2x. So there's a flag for the 32. One AMP. I just wanted to see. Okay. Try this. What is it? Cast to B float torch. Dot two torch dot B float 16. What? B float. See what this does. $150. So, wait, what does the one that... Hang on, there are two different things going on here that are weird. Wait, I'm very confused. I thought, it was only nerfing B float. $50. The heck? Okay. Interesting. I was there for shooters, couldn't break toppers. Welcome. Well, I suppose this is irrelevant because nobody uses this anyways, right? Like the expected value. Wait, then isn't this mean that B float isn't nerfed? I'm very confused. I mean, this is something for sure. Okay, because this gives us... What in the hell? Okay, so this gives us 152. I'm gonna have to go see if it keeps doing that. Let me go figure out why the hell this thing keeps buzzing obnoxiously loudly. Okay. Don't know why my washing machine has suddenly decided to freaking 10x the volume when it announces it's done. 120 decibel fire alarm level. Ridiculous. Ah. Hmm. N and H. We're not writing C anymore. The hell? Okay, I just messed it up. That's fine then. Oh. Because it's batch? Yeah, this is batched input. So it's gotta be 1. Is it times second? It is, right? Really? B T launch base. Where is this thing? Oh, you literally have it none, don't you? It's literally freaking none. And a 2D type. Oh, observations dot float. This is probably the AMP screw up if I think about it, right? Like stuff like this. Okay, so how do I pass? This is kind of fun for today. This is enjoyable and probably useful. Figuring this thing out. Okay. Our batch. Okay. 133 teraflops. If I go down to a more moderate 512, get 77. Oh yeah, let's just check real quick. Flow 32. That's weird. Why are we getting this? Yeah, so it's missing the map mole. Somehow. I don't know how. Really weird. The heck? Oh wait, bot. Something's wrong with my something is wrong with this profile counter. Missing map moles somehow. Yeah. Why is it not counting map moles? So weird. Still no, right? Hmm. That's really obnoxious, isn't it? Hey, Jess. What's up with the title? Oh. Glad you asked. Thank you for the reminder. That is what is up with the title. Let me get more coffee. This is weird. I guess I can do timing as well. We'll do it in BF16 for now then, since it actually freaking works. First of all, if we can get this to peak, I want to see if this is actually going to get near max. It's actually lower. Interesting. Okay, so presumably this is much lower. 28. Yeah, so now $512, like our standard setting. It's actually not terrible that this ends up at 68 teraflops. Of course, when you do this, yeah, you lose all your friggin' perf. Wrong with torch compile? Importing. The heck is wrong with this? Oh, this is just broken, huh? I bet you this is frickin'... Let me see. What version do I have in the Docker? Torch. 2 to 12.8. I guess I don't have version pinned. A 12.8 to 8. I think it's just some weird screwy thing with compile in this version. Welcome, Obito. Yes, you have not shown up for the morning shift. That's definitely how it works, right? Alright, what the hell's wrong with this thing? Why is... Why is this broken? What do I import so that this thing doesn't just break? Good. Well, it's just broken out of the box in this case. It's not even anything I'm doing. It's just the freaking compile op just doesn't work. I don't know why. Oh, you know what? I see it. I'm stupid. I'm freaking stupid. I've literally done this before as well, and I still forget. I hate Python so much. There. Boom. You can't name something profile. Literally, that's what it was. Doesn't that suck? Literally slower with compile. Lovely. Hello? Well, that doesn't freaking help at all. Yeah, there's very little variance in this. Compile doesn't really do much, does it? I also don't see this. It doesn't seem to be doing anything. Maybe it's just not. Yeah, so this stuff is just straight up not getting applied, right? So why is this not getting applied? So this just output a bunch of garbage. Yeah, so this doesn't tell me anything, right? Nothing at all. Lovely. Here that does nothing. Do it this way. What the hell? Oh. Hmm. Interesting. Literally faster without compile on. This is the thing that I always see, is the compile thing just sucks. Like, Torch compile just fucking sucks. That's the thing that I always see. It's like, I always try to go like, oh yeah, maybe we'll get Torch compile, and it just sucks. And like, I've done this in Puffer, I've done this outside of Puffer. So what do I do? Reduce overhead, increases overhead. At least it's getting applied. Nope, that's not gonna do it. As soon as you turn this thing off, better, right? Consistently. Let's see, has anybody ever figured out why the hell? Hey, Kevin. Do you know how to make Torch compile not just be completely worthless? Because right now, this is probably at least the 5th time I've played with Torch compile, because everyone says it's so great. And literally every time it's just completely worthless. Literally makes the model slower. Same thing recent. Hmm. I think we need insight, right? We actually need to set up like torch profiling. Oops. And I probably am going to want to run this locally. Yeah, so let's do this. This doesn't depend on much of anything. Do I not have... I thought I had something locally on this. Okay, so we're gonna set up a full local install, I guess. The Obito. Yeah, I think we're gonna just do this entire thing, right? Try this. And hopefully we're good. And do not break things. And as hopefully I especially do not break my system. We shall see. Why not, while I wait for this, why don't I start on the, oops. Never mind, I suppose it's already done. Okay. Where's NVIDIA? Okay. So we open this big chunky profiler thing. I've not used this before, but I typically do not like the heavy things, but it's time to actually profile stuff correctly. We might even end up having to deal with jacks today. Wouldn't that be funny? I warn you, if we do have to deal with jacks, it's not gonna be it's not gonna be me being like, oh look, Jax is so great. It's gonna be me just being mad the whole time. Okay. Well, that's an outdated command. This. And what do I do? Huh? What? Oh. Okay. See, if I just put this chunk of it over here, you can still kind of see everything that matters. Zoom. CUDA profiling initialization. So how do I see which chunk of this is my actual runtime? Is there like a basic on this? I want a freaking hour-long video. Anybody familiar with this? Okay, so this is the environment right here. These are some environment calls, I suppose. I'm confused as to how the events should all just be right here, right? Yeah, there we go. Not exist. And what am I looking at, right? I don't know what I'm looking at if there's nothing here. Yeah, like this shit is like, I assume that they just have changed the API a whole bunch. And like, now it's just, the old calls just don't work or something. I don't know. Why do I not see... I don't see NVX. Why do I not see... Hey, Tim. I'm trying to figure out... I'm working on trying to profile some basic torch stuff. I'm trying to get a sense of how we optimize small networks and overhead and the like. New env. Yeah. So basically I'm trying to do a much deeper passive optimization because now we're not just in super high data regime where batches are big. I'm trying to do all of that. Yeah, I love LMs. They're just so great. Fuck off. I love that we just outsourced having documentation of shit to that. Can I see the activations at all in this? Like this. This is not it here. Looks like this is it, right? This block? Yeah, it looks like this is the actual thing, right? Yeah, so this is it. Like everything else, that was all just initialization. Go here. I mean, they're just all these like little tiny, just a ton of these little tiny kernel calls, right? But, like, I don't see what I'm supposed to do with this knowledge. It's like, yay, there's some kernels, and they're not spaced correctly, and then the thing that's supposed to fix this, which is compile to generate graphs, doesn't fucking work. Okay, so this gives us 2 point... So this gives us... Wait, if I do like this... Yeah, we even lose some perf from that. Okay. It's like tiny little net. Now, what do I do with this? So without compile, with compile. I guess you know what I'd like to do? I have an idea. Let's just go get... Here. Yeah, I know what we're gonna do. We're gonna try a couple things. Because this is like... This is messed up. You know? Okay, so this is slower, right? Okay. So I mean, regardless, like, certainly if this is supposed to be a useful thing, it shouldn't just be slower. 3.2. Yeah, it shouldn't be slower out of the box like this. Cool. Let's just remove this. I'm gonna try to get this. I'm gonna try to get Grok to put this in jacks. I want to see. I mean, the thing is, I expect that this should be slow because compile doesn't friggin' work. Using envs as template, which are the best to copy from? Well, the one that's literally called template is the starting point env. Simple multi-agent env snake. Simple single agent env, very simple single agent env is like squared. Whatchamacall, convert is fine. What's the other one? Target is fine. Neural MMO 3 code is a decent, like, longer env. Yeah. In the docs. Is in the docs. I'm letting this do this. The goal here is not that we're gonna necessarily, like, oh, now time to port to Jax. It's to figure out what the hell's wrong with Torch. Yeah, give me a few minutes, folks. I will be back directly. Yeah, FBI, I know. I'm just doing something, don't worry. Alright, so it's well known that I hate jacks. What the hell am I doing? Um... I am just trying to get a comparison to see if it's the... Basically, to get an upper bound, I'm just trying to see how well you can do with really small nets. And if this is, like, magically better. Moving. Well, I don't want to move to Jax. I fucking hate Jax. It's a terrible library made by people who think that they're much cleverer than they are. Maybe not made by people. Maybe the Jax devs are probably pretty good. I think the whole like stuff around it though has just become completely stupid. Like people just write such garbage code and it's still slow. Before you had decent code that was slow. Now you have terrible code that's slow. Right, let me figure out. Yeah, pretty much. Like, oh, we need React dev. Oh, yeah, maybe you're just bad. You're bad at everything. Go away. Just like, ugh, the frameworky thing is just... Is this... See, this shit is just like, oh, look, we made it so nice, but you didn't. It's just like, every single time I go to use it, there's some versioning bullshit. Let's actually not pollute this chat. Upgrade your QDNN. But then how do we do that? But this is like QDNN specifically. Oh, wait, hang on. It's like so obnoxious. They're not even, none of these are even close. What the hell? 8.9. Why does this even... Well, yeah, and it's just like, oh, we made it pretty. And it's like, okay, you made it pretty, but you also, it doesn't fucking work. Like, every single time I've tried to mess with it as well, it's something like this. So can you blame me for just saying, oh, okay, these devs are dumb? I'm not gonna do with that, thank you. Oh, lovely. I'm sure this will break nothing at all. Not found. It's just such a dumb library, is what it is. What does it do? It cannot be. Well, I mean, if you want to go implement your own PyTorch or Jax, be my guess. But, like, I'm not using it for environments, dude. I just want to do, like, run some timings. And I forgot that this entire, like, ecosystem is stupid. Or at least I forgot it's this stupid. Like, I don't know how you bork and install so bad. Great. Okay. Just fix this. In Python was the bottleneck. Well, sometimes it is. It often is. An actual good language. Well, because there aren't any actual good languages for everything, really. At least no popular ones. It's like C++, you're an idiot. Rust, you're an idiot. Go, close, but you're still an idiot. C, pretty good. Strings are really painful. A bunch of other things are really painful. You kind of don't need that level of perf for literally everything you do. Yeah. The problem with all the new little, like the new and trendy little programming languages is you're basically just tanking your project by writing it in that. None of the mainstream popular languages are like good, really. Like the least bad thing I've found is just Python plus C. But it's like it's still so obnoxious. Um I love having this stupid thing just not. Come on. I don't ever do like this type of crap where I'm like pasting full chunks into a language model. It's like, oh, we solve competitive programming. We're, the best model. There will be no more human programmers, and it can't write a 40-line script. Like, piss off. Actually, what's gonna happen is after this, we're gonna have to do, So if this is better, then I'm gonna have to try a bunch of other stuff in Torch, I think. If this is actually worse, then it's gonna be really funny. Like, let's see. So this is like just freaking TPUs, right? Wait, peak compute per chip is 275 T-flops. This is just like the mesh being. Interesting. Yeah, they charge like $2 a chip. Oh wait, this is 5? Oh, that's 4 that's crazy. B4 pod per chip hour. Yeah, so that's crazy expensive. So I think that they're just like... Oh, now it's just flailing. Lovely. Literally the same error, right? Can I figure out what's going on with this stupid thing, even though it's dumb Jack's code? I don't know what this lower is. Like this dot lower bullshit. Anybody know what the hell this is? Okay, it just calls it. Where's this cost analysis? Did it just make this shit up? Oh, it's literally built in? Well, I mean, that's really cool, but does it work? Okay. Well, this gives us something. So it's actually, this says it's faster in Torch out of the box, right? Thank you, unnamed. I got it though. Think I caught up Love Constellation. Oh yeah, that's what we're gonna get back to. So the idea here, to give you a sense of what I'm doing, this is not just random unrelated perf optimization. The idea is that the higher cost points that Constellation is finding, a lot of them are going to be like lower batch sizes and stuff, where they're not going to use the hardware as efficiently. So I'm just trying to see if we can optimize hardware more effectively for smaller networks, etc. So the outcome of this so far is let's see. What happens if I do this? What happens if we just take Jax and we don't compile? So Jax is actually, look at that. So Jax, you get the expected speed up with compile. It's just that the speed sucks. I suppose, though, we should try to make this more conclusive. I sent some NVIDIA folks an email this morning. One of the things I'm really hoping is I could get some NVIDIA people who actually know how to really optimize GPU perf. Because, like, the small nets are just running at literally 3% max theoretical throughput. Okay? We will try this thing. So, this is our initial benchmark. Why would I send DeepSeek an email? They optimize big models. Ooh, that's faster, isn't it? Oh yeah, so that noise gen is gonna dominate, right? Yeah, it wasn't that. Alright, why is this thing faster? Yeah, pretty much that, Tim. You see how it's literally already starting to write garbage? Like, what the fuck is this? Or iLoop? Oh, well, yeah, that's cheating. You can't compile the entire training? Okay, I see. Yep, no faster. So that's gonna try to like, yeah. I see. So you can't compile this or it. Okay, so hang on. I know what we'll do. Hey, Plasma. Welcome. Good to see you. Oh, I missed Nicholas. Having issues with DQN. What's a good way to test it? Some good tests or things to look into. Yeah, DQN it's the thing is it's such a weak algorithm that like I'll tell you that I did do it recently-ish with big batches and like good optimizer and stuff. And I was able to get it to do like cartpole. Like cartpole should be a consistent enough task. What's a good test to check the code is good? That's the problem with these algorithms, right? The problem with RL algorithms is the test is whether they solve, fixed known environments. That's why it's hard. It's not like you write a sine function and you can check the outputs of a sine function, right? Worked on Boyd's, yep. Reward, algorithm got it to train successfully. Awesome. You got a PR for it? You got some cool Boyd stuff. We'd be very happy to see that. Studying learning dynamics, not really whether performance is good. Reading is correct. Yeah, but that's the problem. There's not like an easy check for that. Low-key hustling this. I mean, this is just me typing shit into a stupid LLM. This is like nothing remotely impressive. This is completely brain dead. Man, way to type shit into that LLM. Like, this is just me, like, debugging stuff and, like, trying to get some quick benchmarks in an area that, like, I don't normally work in. Sweep it then, man. That'll be cool. Like, this just did not. Hang on. Still grinding? Oh, yeah. Well, I mean, I'm actually, while I'm here, I've got a pretty strict schedule. It's a pretty funny schedule, actually. Let me go get my couple sets in and I'll tell you. Alright. So here's the schedule. I wake up at 7. Actually 7:10 because screw that. One snooze. I make myself coffee. I go lift that bar once. I go run a little over 5.5 miles. Hour-long run-ish. Sort of hard course. Then I get back, get a shower around 9. Around 9:30, I take care of some emails and administrative stuff for Puffer. Get breakfast at 10. Streaming at 10:30. Streaming 10:30 until about 6 p.m. Have dinner at 6. Back to work at 6:30. Either stream or I work on client stuff in the evening. off stream until 9. Oh yeah, 9 I do an hour of stretching, working on flexibility till 10, and I go to bed. And then throughout the day while I'm doing my stream, I get about an hour worth of lifting in. The sport, an important counterpart. Pretty much, yeah, it keeps me sane. It keeps me healthy because I'm sitting in a chair all day otherwise. What's this? From Torch Backends, import. Let me see what you've given me here. I was able to get a job and I'm texting you at my job. Oh, hey, man, awesome. Congrats. I just saw that. Pretty much same exact speed as before. Mr. No Name. Max. Oh, yeah, that's a decent thing. Hang on. I do remember that as being better sometimes. Whoops. We'll see. Max, autotone, no graphs. That's higher, right? 442. Still lower than I just do with the let's see if this is even better. Yep, that's what I'm trying. It's really obnoxious, though, the startup on this. Oh, and it sucks. Yep, that sucks. Pending uninvoke backwards. Oh, that's interesting. Oh, way faster. Holy. Okay. So, yeah, it was doing grads. Max. Yeah. So it was actually, we'll have to see how the compile modes affect this afterwards. But it was the fact that it was storing gradients. We also want to get rid of this, like, RNG bullshit if we can. Okay. So, here's the torch one. And then this just directly gives us 8.9. Jax 1. Okay, cool. And then we do without compile. So Jax without compile sucks, right? Like all the damn perf comes from it. PyTorch likes its compile too. It generally seems better without it though, like. But basically this just means we want to compile like the entire training loop if we can, right? Jax is not like magically fast. Let's see if the mode changes anything. It does. You actually do need max auto tune. But without coup de grace. I would like to get rid of this noise calc. Oh, and we also didn't try. What just happens if I do this? Do I actually get like reasonable perf? In Torch version, compile the model to. What do you mean in Torch version? In Torch version, compile the model to. Isn't this it? Oh, you're saying, do I need to compile this separately? Is that what you're saying? Pretty decent Terra ops, actually. Holy. Like this? That doesn't seem like it does anything. Yeah, that doesn't do anything. It's already compiling the full model when I do it this way. I mean, this is like massively, like the fact that this, literally just like this super simple model equals, I did that, right? I just did that and it doesn't. I think you're behind a minute on this stream. Because like I did that and it didn't make a difference. Okay, this doesn't change it. This is nice. Model.compile. Wait. I thought I did that, didn't I? If I just do here, right? Model equals. Oh, like this, dot compile. Yeah, we'll try your thing. Oh, I see. Like this. Like this, right? 10.97. Hang on, is it variance? Yes, variance. I think it's the same, man. I'm pretty sure it's getting compiled. Right? Okay, this is way better, right? All right, so we didn't have a good enough warm up here. Now let's see, 10.79. Yeah, that compile doesn't do anything, man. It's the same. Okay. Okay. So, that's kind of interesting, isn't it? We are able to get up to 10 teraflops on really small nets. I think that we can actually make Puffer like way faster on some of the really small models. I think it'll be pretty cool. So, I think how we do this. Yeah, there's so much to be done here, my gosh. That's a bigger project, isn't it? But at least, like, I think that this tells me at the very least that... Here. So we can just go based on the compile, right? Okay, there's like at least a 4x speed up to be gained here. This would explain why, yeah, I mean, this, like, actually, it's like an 8x speed up, isn't it? Because this is also BF16. Yeah, so we can just make Puffer, like, stupid fast. Actually, can't we just figure this out right now? So we're gonna do... What? Oh, because it can't be numl. It has to be n, right? $253 3 million. That'd be kind of nuts, wouldn't it? Say there's like overhead for, but yeah, that's still crazy. Okay, well, I mean, there's gonna be the LSTM and everything involved, but like, Puffer can be way faster. And Jax isn't the solution. We just did a bunch of profiling as all FPR. We did some profiling, seeing like, okay, what happens if you really try to optimize small networks? And this is what's happened. I think I want to do, so it's 4. What I'm going to do now is I'm going to go do a couple sets. I'm going to switch over and probably work on the meta stuff for a bit. And then we'll see what I do with this. But, like, this is the other side of what I wanted to do with Puffer. And I think that this is, like, this is a very, very strong and encouraging result at the very least. Probably what I'm going to do based on this, right? Network size is tiny, FBR. It's just, like, 16 to 128 to 16. But, like, the idea here is, previously Puffer was optimized for small nets with big data batches. Now we're also having it optimized for small batches. And I think that this max autotune actually can get cached as well, right? Yeah, this max autotune will get cached. Protein suggest is pretty slow. Yeah, that's kind of this annoying bit about the Gaussian processes. There are ways to mitigate it, but you're right. I need to fix that as well. I mean, this will all be, I think, part of Puffer 4. I think Puffer 4, I think the science bit is going to be the really large-scale analysis, and then we're just going to, like, crush speed. That's going to be pretty good. There might be some algorithmic stuff as well, but I think that the priority is going to be just, like, really good science and analysis, crush speed. Run 200 of the sweep. Yeah, so that's because there's also downsample equals 10, I believe, so it's 2,000 data points, 2,000 suggestions, and Gaussian processes are cubic, if I recall. I've actually, like, done some small stuff to mitigate this in this branch, but it's going to have to be changed fundamentally, I think. The good news is I have nothing else to do for the most part for the next quite a bit. Like, I have some client work to do, but then being here at this, where I am here, it's like, there's basically 0 friction and 0 overhead to every other part of my life. Like, I just get a lot of time back that I don't normally have. Suggest does 1,000 train steps inside of it by default. Oh. Well, that's bad. Heh. Yeah, I think this is one of those obnoxious things because the way to test changes. I think that what we would do for this is, like, let's say that we're going to take Breakout and Pong as our test environments for the hyperparam sweep. And actually, if you would like to help with this, the way that you would do it is you would get your baseline sweep, full sweep of Pong and of Breakout with the protein as it is now. And then you would make your changes to speed it up. You'd rerun the sweep, and you'd see if you still get the same like approximate distribution of points, or if it messes it up. Where will the main speed gains come from? Missed most of the stream. You're gonna get some from BF16, and hopefully you're gonna get some from BF16, and but then mainly you're gonna get some from. We're gonna have to do compile basically in a way that I haven't done before. The barn. It is a warehouse. We've got warehouse. We've got the gym equipment. Servers in the back. All right, so here's the plan. Let me use the restroom real quick. Let me do a couple of sets. I'm gonna switch over to meta, and I'm gonna see if I can get them something because they're like trying to get baselines and having a tough time. This evening I have some client work to do. I've got like 2-ish hours. I think in 2-ish hours I can hopefully get the meta stuff in a good enough spot that tomorrow we can do either full work on Viz or full work on the client or full work like the new seaport of the client, or we can do full work on this depending on what I'm feeling. And it's only Wednesday, and then we'll basically have, in just the first few days I've been here, we'll have set the groundwork for the whole of what's going to be the next update, which is pretty solid progress. All right, I'll be right back. Okay. I think I said I would set up the meta stuff on. I have it on a different box, don't I? Let me figure out what they've told me to do. Let me just go find their thing. Pip install. See? Okay. Um. Ah. Lovely. I'm trying to think what's the easiest way to just like set this thing up on its own. Okay. Torch. Dropping frames? No. What's wrong with this? Is my internet dead? Doesn't seem so. What's wrong with GitHub? Are you serious? Oh, lovely. I go to, wait, is it me, though, or... If I go here, does it load? Yeah, it's GitHub. What the hell? That's bizarre. Okay. Yeah, it was just some weird thing. I don't know. Good now. Hey, Convert. No attribute get game. Lovely. They changed it again. Changed it yet again. Changed it to get mission. How the hell is this not in there? That's... Yeah, it's okay. Well, I'm just gonna go insane with this. I'm just gonna go completely insane. It's like every single time I pull something, there's like new bullshit wrong. Literally just gets... Yeah, it's just insane. It's like I want to help these guys, it's just they don't make it very easy for me to help them. When things are like this. Now, like, what the hell is this? Like, it no longer creates the same thing. Okay, well, this runs, but it's not the environment that we want, right? Yeah, this is not the env. I suppose what we can do... I can do this. See if it does anything. Oh. Alright, so this doesn't do much, right? Maybe I can figure out where this comes from. GPU utilization metric disabled. The dashboard. It shouldn't be, but it appears that it is. Oh, you know what? Yes, it is. It's this specific branch that I'm on. There's something weird with launching that thing from multiple processes, so I disabled it for then. So yes. What the hell? Where? So this is gonna go into... Can I just look up the name? Yeah, I literally don't see. Yeah, I don't see where the hell these are. Um, nope. Drive me nuts. Okay, well, it's like for the third day in a row, it's like I try, but I can't. There's like only so much I can do. It's not productive for me to just sit here like trying to guess what the hell with the repo. Um, so I have an hour and a half. There are sort of three main things, I suppose. I think I want to start on the perf test stuff though. I mean, it truly drives me nuts, but like, what am I supposed to do? I'd really like to help them. Okay. And right, so what I was gonna do here, for a breakout. Okay, so breakout is a totally different config, right? Yeah, so you can see it's a bigger network, right? The bigger network, they can definitely go faster. So baseline 170K. Interesting. It actually just gets slower with bfloat under defaults. Interesting. PufferLib's awesome. PufferLib just rocks. Okay, so this is a slight perf enhancement. Same exact thing. Okay, so we can't do photographs. We need to fix this. Nice. Trying to see if this is... You may want to look at... It does compilation correctly? Okay. Hang on. I figured it was just broken in that, and I was like, I can just update to the PyTorch run. But I think they just ported it, right? Okay, let's see. Are you sure? Because it's giving me these errors inside of... It's giving me errors inside of the optimizer, though. I mean, this looks fine to me, right? Follow the policy. Yeah, this just, like, runs with Atom. So far. Might not want to change the compile mode. Okay. Let's say I take your word on this. Good morning. 4:30 p.m. here. Good morning. I see. Well, okay, here we go. We're up to 240K. We only have 256 Ns. So this is going to be quite... The goal is going to be to have to compile the entirety of train. Let's just go grab the, wait, was it? I wish it would give me a error message that does not suck. Backend inductor raised. Super annoying. Okay. So you can't compile this. This should not break. I think this should be fine for compilation, right? Oh, I think it's being really stupid right now. Yep. It thought too hard and was stupid. I mean, this is basically like glorified RAG is the thing, because like these models are just so incredibly stupid. It's like piecing together Google shit, honestly. Does this do anything? Let's do anything. Wait. Hang on, does this... Am I dumb? Advantage row. Not sure there's a problem. Well, apparently here it's breaking on the advantage calc, and I didn't attempt to do anything. So presumably I'm missing something, right? Of course, the model just added completely stupid shit to my code, so that doesn't help. Huh? This isn't even any different, is it? Oh, you know what? I confused it because I gave it the wrong file. I'm dumb. I should at least go look. Here it is. I don't know why I used the LLM. I should have just done this. Hey, Mage, you're welcome. What am I currently working on? I am trying to, well, I wrote some scripts that basically say that we should be able to make PufferLib way faster with compilation, but not in the way that I was previously using compilation. So that is going to be the objective, is one part of a much larger thing for Puffer 4, let's say. I think we can make it much faster, actually. There we go. Ah, because it has to return nothing, right? No, it does. What is this? Oh, I see. I see. It's supposed to return void. What if we only torch compile some of the helpers? Then it doesn't work because you need to compile the loop. The loop is the thing that needs to be, like, fixed. Because the thing is, the loop is so fast, it needs to do the whole thing at once. Custom PPO so far for V4, yes. Possibly some small algo changes, but... where is this failing? Wait, this should work now. Is this a thing? That'd be kind of funny. Ah, I see. Which compiles its limits. Do you know what the difference in overhead is? Because like, shouldn't it combine the kernels for small models? Or do you literally just have to write a custom thing to get it to fuse? I'm almost like, literally if we just had all the layer types in is like easily accessible, relatively nice chunks of CUDA, I'd honestly be very, very happy just doing all this stuff in C. Because, like, the amount of time you spend trying to debug and use all these overbuilt, shitty profiling systems to get the code to just not be unusably slow is just pathetic. When you're rolling out the whole model. Yeah. It's like, it's honestly so stupid that we've decided to use, like, that everything should just be shitty Python, and then we build shitty systems on top of the shitty Python to, like, escape the performance nightmares. And then we're still not at anywhere near MFU. Well, this at least did something. Oh, okay, cool. So this actually did something, right? Yeah, this actually did something. This might end up becoming the Joseph just rewrites Torch arc. I don't know. It's just so freaking sad. Like, the state of software. Set it up. Major, it doesn't let me set it at the start of the damn stream. That's the problem. If it could just default it. If you have a way so I can default it, that would be great. But otherwise, it just clears it every time I start the stream. And yes, if you start a stream on Twitch, you set the category. But I don't start the stream on Twitch. I start it on Restream, so it goes to all three platforms. And the integrations just suck. PPO in 1.cu. The perf gets wild. Yeah. The problem, though, is if you do that, Lucas, like, nobody will use it. Like, literally nobody will use it. And then you don't even have, like, you don't even have the right algorithm at that point. Because if you just implement, like, vanilla PPO, it just, like, that's not what you even want. So basically what I think happened, right, is, like, you do need the flexibility of having some tools. You can't just .cu everything. But, like, the solution is not PyTorch either. The solution is, like, some collection of nicely implemented reusable chunks of, like, individual layers, perhaps individual optimizer routines and the like. And as usual, we just went a couple layers too high. No default? Yep, lovely. Thanks, Twitch. Is there a plus equals or somewhere? What's the TLDR of today's progress? We can make Puffer way faster. And I'm working on how. For the ballpark? No idea. Potentially a lot. Ah. If I do this. 3 large kernels. I mean, that's like going to be a cool and very impressive project. That'll absolutely be a very impressive project. I mean, yeah, you could literally get that to be 100x faster than PufferLib on very small models, right? What, like 100 million to billion step per second training, some crazy thing like that? Close to a billion? Yeah. Is that actually like a reasonable net as well? Wait, let me think how much that could potentially be. Can you actually get a 128 dim? Hang on, let me think. Teraflops. Is that like 128 hidden as well? I think you can get that. Gradient accum is the bottleneck, yeah. That's funny. Okay, but like realistically, right, if I can get this to... If I can get high MFU above... Let's say when you get to 1,000,000 parameters, I get good MFU, and I have like a reasonable decay down, then it's like pretty good, right? Because it's like, how much do I care about... I definitely don't care about like super optimizing nets under 100k params. Oh, 32 hidden, yeah. Like, do I really care about hyper optimizing nets under 100k params? Probably not. Do I care about nets like 100k to a few million? Yeah. Like, you can do useful stuff with that, right? Does it help me to get, like, without crazy batching params, does it help me to get 100 million instead of 5 million steps per second on some of the test Ms? Yeah, that actually does help a lot. Right. Sort of how I think about stuff. Written 1 mil params torch is fine. Well, it's not fine by default. You actually have to work very hard to get it to be fine. Heck, I have it better than anybody else has it, and this is still way slow. Like, this could still be way faster, right? We do RL at millions of steps per second standard. Like, for research, for clients. So it's pretty good. But, like, it could just be so much better. And just, like, everybody asks me, how on earth did you get it that fast? And I say, how's it this slow, right? Literally nobody understands what hardware can do anymore. It's nuts. Nobody understands at all. Okay. Moonbot and use. Okay. Add Moonbot. Hang on, that's like crap. I'm gonna have to do it on I have to do that on a separate browser, I'm pretty sure. But I'll add Moonbot. Thanks. 20 elo. Yeah. Yes, I'm pretty sure it's like an action formulation and pruning thing. Tiny models transfers to 100k params. Run the whole sweeps in seconds. Speeds up research so much. Let me think about that. You're not wrong. You're not wrong. I mean, honestly, like, this is a lot of the stuff we're doing now. Puffer, our goal at the moment, we're going to have the largest scale, like, analysis of reasonable experiments in Puffer 4.0. And you're going to be able to play with all the data very easily. But I have noticed, right, that a lot of you're really not getting a lot of speed up when it pushes the model sizes down and it pushes those params down. And we could definitely speed that up a ton. I guess one thing you could do, right, is like, I guess we could have some standard network types where we have them full CUDA, or we could have some standard network blocks being full CUDA. Honestly, that would be really nice. I just don't have anybody around that, like, does that type of work. Because we've had to hack, like, for instance, the core LSTM we use, we've had to hack that thing so much. It actually would probably be kind of reasonable. What are you doing for your nets, though? Are you doing, like... Do you have your own naive matrix multiplications? Or are you, like, hooking into Blast? Or do you have some optimized thing? Like, what are you doing for the core... Like, the core linear algebra? Yeah, that's what I'm doing. I wish I could persuade you to come PR some of this stuff to Puffer. You'll get quite a bit of reach with it if you do. We have a heck of a lot of people hacking on RL with this. The cool thing with Puffer, right, is, like, we've also been able to do this for the env side, and it's really not that limited, right, because you just write arbitrary C, and we get that to be fast enough. LSTM and CNN, oh. Well, we do have implementations of these. They're just crap, right? Like, here. I mean, I did, if you want references, these match the PyTorch ones exactly. Where's it? PufferL. Here. Here we go. So right here, inline assembly. But are you just doing naive map moles then, or, like, ideally you want to do some blocking, right? Because we have right here, so this is like mini PyTorch, right? And it's really naive, just like silly looping. We have the LSTM in here, we got layer norm, we got a bunch of stuff. Like, I wouldn't want to just port this directly to CUDA, because this is going to be way less efficient than using, like, nicely blocked mapmole kernels. That's, like, one of the main annoyances, I suppose, that's preventing me from doing this type of stuff more broadly, is, like, that stuff actually matters, and that stuff's really annoying to do. Also, default PyTorch CNNs have been really slow, like, really, really slow. No puffer. Bind into code. I don't mean depend on puffer, right? I mean, like, if you write some extensions. Other way around. Because, like, you're gonna limit it a lot, for instance, if... I think the other thing that's gonna be tough, right, is... Oh, yeah, at those speeds, you really do need the environment to be in CUDA, don't you? That's tough. Well, I guess, Lucas, there is a project I've been thinking about doing where I think it wouldn't be that hard to get CUDA-compatible versions of a lot of the puffer envs. You basically... Like, our stuff is just no memory Alex minimal C anyways, right? You would basically just copy it such that one env is one CUDA thread. You wouldn't parallelize it any more than that, but that's kind of already enough, right? Env is in CUDA. Well, you say it's not a big problem, but we've got some pretty big envs, right? Buffer's only a few thousand lines for all our core training and stuff and hyperparam sweeps. We have 50,000 lines worth of environments. Is that even like a smart thing though? I'm trying to think. I actually don't know enough about GPU architecture to know like what speeds you're gonna expect out of your env per core. Because actually, I might still be okay. Mario env is 3K. Okay, 3K is neural MMO is that long, so I'm a little suspicious of that. I'd believe 1.5. M sits inside L1 cache. But like that's gonna really limit what M's you can use, right? Like how big is that cache even? I have no idea off the top of my head how big that is. Okay. $1.8 KB. So wait, is it? So yeah, the end. How the heck does that work? Wait, you don't need the source there. You need the memory for the env to sit in there, don't you? And then you have a bunch of copies of that? Hmm. Neural MMO in as few lines as possible. I mean, without golfing yet, I kind of did, right? Like, my PhD, it was over 10K. And then I just wrote it. Have you seen the code for this? Like, this is one of our heavier environments, right? So this is, I forget where it is. It's like 3K. But this is just brain dead, top to bottom. Like, write the environment code as simply as possible. Obviously, you can cut a lot out of it if you're, like, okay removing details of the procedural generation and, like, details of things we use for rendering, right? Like, to make it possible to do nice rendering. Um, and then, like, there are aspects like other features that aren't really heavily integrated but are kind of cool, right? Like a full game. I'm working for another half hour, yeah. Okay. Oops. I'm literally just like bisecting manually. Strip it down. Well, I mean, there's kind of limited value in that, Lucas, because like I'm going the opposite way ultimately, right? The goal is to have Neural MMO 4 be closer to a full game that has all sorts of new types of challenges that are really going to test out RL algorithms and elicit, what we can really do. It's not going to be towards like a simpler, smaller environment. Obviously, I have such a high emphasis on simplicity that the goal is like maybe Neural MMO 4 is only 4 or 5,000 lines and is several times cooler and has way more stuff in it, right? But it's not going to be Neural MMO in 1,000 lines with a bunch of stuff removed. I don't know. We'll see when I do it. I have so many things to do for this field before I even think of stuff like that. No, we do not have our own Binding of Isaac, man. No, we do not have all the things. This debugging shit is so obnoxious. Yes, it technically is. But I can make it better than it is now. Wait, what is this thing? Am I following you? I should be. Oh yeah, I am. No, I'm not. There we go. Of course, the cool people building stuff and posting nothing. Oh yeah, I saw this. Cool. We now have M's and C now. Yeah. I really like these little plots as well. This is fun. Alright. You're golfing a little bit to fit 200, though. I will say you're doing the tiny grad thing and golfing a little bit. It would be better at 300. It's still super impressive, though. Wait, how the hell is this? Yeah, so something is just massively screwy. Oh, you know what? I wonder... Does this modify ratio in place? I see. Yeah, okay. The tiny grad? Oh boy, thank you. Tiny grad's a really good project. The golfing thing is kind of dumb though. Okay, that is something. Hey, Finn. Finn, meet fish. Fish, meet puffer. Thanks. How's the drone stuff going? Ooh. Solid. I'll be very happy to see that. Hmm. Interesting. That is something, though. What MV you running there? Wait, hang on. Wait, hang on. What are we seeing here? You can always ungulf it. Having all the code on one screen really helps me. If you really want that, just get a vertical monitor, man. Like, having it that compact is kind of nuts. Telemetry is good. Solid. What env? Breakout, but we're trying to mess around with compile. 29 more for Swarm Simdariel. Yeah, easy 40 grand worth of drones. Not impossible, mind you, but it would take, there would have to at least be, like, some reasonable contract behind it for that to happen. That's too much for me to spot just for the hell of it. The meta guys sent me back some instructions on how to get this thing running before they replace fireworks. They're raining firebombs. Well, the hope with the drones is that eventually the drones get so good that it's pointless to have soldiers. So if two countries want to fight, they just blow up each other's drones until one of them runs out of money. And then it's like, okay, now we sue for peace. Anything more is just a stupid war atrocity. So I don't know. Weapons not always bad. But you can also do lots of other fun stuff with them, of course, right? They're like also just they're really good. They're really good for just studying multi-agent intelligence in general. Just like having agile things that fly around and coordinate is really good for that in general. Economic war we're already doing. Yeah. That is the ideal outcome, I would say, right? Multi-agent combat drone PufferLib. There have been like things that aren't that far off of it. I don't know. I'm not really opposed to that type of stuff personally. There's like stuff that I would think of as cooler, you know? I can think of all sorts of cooler stuff than that. Wait. What are your cooler ideas? material science, biological sim, accelerating areas of science heavily dependent on sim. Those are some really cool ones. Like actually understanding intelligence as well in like a very efficient way that's not throwing hundreds of billions of dollars at this point at freaking bigger and bigger language models that like are not learning through interaction at all and like really don't tell us very much about intelligence. All sorts of stuff we can do, guys. What the hell? AIXI model. What is this? Oh. Where did this come from? This is a bunch of math. Does this thing actually work? Is this a thing that you can implement that actually works? Or is this like one of those 40,000 feet in the air things that you can't actually use? This is gonna drive me nuts. Like, not be computed. How to model the world. I do not like things that cannot be computed. I like things I can implement and test. Are the computable approximations any good? Can we run an experiment and solve Puffer? Solve all the things? right? Like, this is what I think. This is how I think about these things. So obnoxious. What the hell? Bruh, like, why? This thing isn't even in here. Is it in here? Okay, is the provably best time agent. The thing is, your proof bounds suck, right? So that doesn't help. Like, basically nothing in the theoretical side of RL does anything. Like, you're improving on a bound that, if there even exists one, is so low as to be useless. Alright, well, these guys are, like, annoying the hell out of me with this. They've given me, like, 5 different things at this point, and none of them work. So I cannot help them. But anyways, I am going to go get some dinner. Thanks for tuning in, folks. I probably have some client work to do in the evening. I'll be back most likely 10:30 a.m. tomorrow Eastern. One moment. For folks who've been tuning in, welcome. I do high performance reinforcement learning, research, dev, tons of stuff. It's all open source. It's all at puffer.ai. If you want to help me out for free, start the repo. Literally it. Join the Discord to get involved, and follow me on X for all the content, including educational stuff if you're new. So thanks, and I will be back tomorrow. Bye.